Yeah, in this video, we'll talk about these operations, that is reversing a list, that is array, left shifting of elements, left rotation of elements, and this right shift and right rotation are similar to these. So I'll be discussing these operations. Let us start with reverse. For reversing an array, we have two methods. Let us look at the first method. So in first method, we will take an auxiliary array, the extra array. So we'll take one array, let us call it as B. In this array, we will copy all those elements from the actual original array and we will copy them in reverse. So from last element we'll copy. So the first element that we'll copy here will be 4. 4 is copied here. 12 is copied. Then 2 is copied here. Then 7 is copied. Then 10. So in this way, we will reverse copy all the elements. So the elements are reverse copied. Then, now we will copy these elements back into the original array. So corresponding elements, same location elements will be copying. So this becomes 4, then this becomes 12, and this becomes 2. So we'll replace the elements in a original array. So this is first method. In first method, we require an extra array. How much time it is taking for reversing the elements? So reverse copying from A to B. So from A to B, when you copy the elements, the number of elements are n. Then again, you have to copy the elements from B to A. So B to A, again, there are n elements. So total 2n. So it is order of n. So the time taken is order of n. Now let us write down the code for reversing the elements using auxiliary array B. We have to copy the elements from A, that is from last index, in B starting from first index. So we will take two integer index pointers. I starts from there and J starts from here. I will be decreasing and J will be increasing. So this can be done using a loop. I starts from last index is length minus 1. This is length minus 1. And also we need J, that is J assigned 0. So we'll be doing two initialization, then semicolon. So we can have two initializations in for loop separated by comma. Then comes semicolon. How long we should do this? Until I reaches 0. So beyond this one, we should stop. So I greater than or equal to 0. So when it becomes less than 0, it should stop. Then every time I should be decrementing, okay, comma, then the J should be incrementing, J plus plus. Then while scanning through this array from back side and this from front side, we have to copy the elements into B at a location J from A from location I. This part is reverse copying the elements. Then after doing this, we have to copy the elements from B to A directly. So for this, we can start from here I, that same I can be used here also. 0, 0, then 1, 1, then 2, 2. So 0 is copied in 0, 1 is copied in 1 and so on. So again one more for loop for I assign 0, I is less than length. We have to go up to the last element, then I plus plus. In this for loop, we can copy the elements from B to A. So elements are copied in A from B. This portion is reverse copying, then copying the elements from B to A. Now from the code, if I see, then this statement is executing for n times, for n elements, and this we know well that the condition part, this one, will be one extra, so this will n plus 1. We are not concerned about this one. We are concerned about the actual work done. Then this statement is also n. See, these loops are not inside one another. They are after one another. So its time is separate, its time is separate. So it is 2n. So the time is order of n. Time is order of n. So this is one method of reversing. Now second method I will show you. In second method, we can scan from two ends of an array and interchange the elements, swap the elements. Like first element is swapped with the last element. We will swap these two elements, interchange them. Then these two elements are swapped. 3 with 12, and 9 with 2, then 15 with 7, then 6 with 10. We need two indices, I from here and j from here, then interchange the elements. So copy 4 here and copy 8 here. Then decrement I and decrement j. Then interchange the elements. So 12 here and 3 here. So in this way, if we continue, rest of the elements will also be interchanged like. Similarly, if we continue, we can interchange rest of the elements. So when we should stop? When I and j has came on the same place, or I became greater than j, we should stop. So in this way, we can reverse the entire array. So how much time it is taking? We have to scan through all the elements. How many times? Just one time. So time is how much? Order of n. We are swapping total n elements. We are accessing total n elements. Now for the same thing, I will write down the code and show you for reversing. We want I starting from 0 and j starting from length minus 1. Then this can be done using for loop. And how long we should continue? As long as I is less than j. When I becomes greater than j, stop. Elements are over. Then I plus plus j minus minus. What we have to do each time? Interchange the elements, swap the elements. So for swapping, we take some temporary variable and in that store a of I. Then in a of I, store a of j. And in a of j, store temp. That's all. This is the code for reversing array. So we don't need an auxiliary array for this one. So the time is order of n. Now next, let us look at left shift and then left rotation. Let us look at left shift operation. I have taken a small size array of size 5 and I have 5 elements in that one. Now what does it mean by left shift? We want to shift all the elements on the left hand side. Let us see. So from which element we should start? From this element, first element. If I shift this 6, there is no space here. 6 will go out. Okay, let it go out, no problem. Then 3 will come here and 8 will come here. Then 5 comes here and 9 comes here. Then this place is free, so we can put 0 there. So this is left shifting of elements. We will lose one element in this one. Yes. So it means if I have to shift right, then I should start from here. We will lose the last element and all the elements will move one step forward and we get free space here and it is 0. So just the direction is different, left and right shift. So just the direction is different in left shift and right shift. This is shift operation. Then what is rotation? The deleted element, the first element that you got, you copy it in the last location. It means that 6 has not removed, but it came here. So it is rotation. That's all. So shifting means just moving them. How many spaces you want, you can move. Usually we move by one place. Then rotation means the deleted element is copied at the last. This is called as rotation. How much time it has taken? We have moved n elements, so the time is order of n. Shifting takes order of n time. And if you have to rotate, you can keep hold of the first element and you can copy at the last. So this is called as left shift and left rotation. Now what is the use actually? So for explaining the use, I'll show you. Now usually on display boards, LED display boards, we find that the advertisements are scrolled on the display board, that is LED board. For example, this word welcome is there displayed on LED board. So this can be constantly displayed like this. Assume it is LED board only, but actually it's an array. Now we want to show it as moving, scrolling. So what we have to do, this should move this side. So remove W, move E here, move L here, and C, O, M, E, and blank space here, that blank space here, that blank space here. At the end, add a blank. So W is gone. Now if I repeat again, this all letters will move shift on this side and E will be gone, then L will be gone. So it looks like as if this word welcome is going away. So it's scrolling. Now followed by that you can start adding some other letters then. So the advertisements will be moving right to left on the display board. So with the left shifting we can show them as scrolling advertisements. If you want this to work just like this welcome word is going around and again coming back, it's like rotation. It's like rotation. Then for that, this deleted letter, you can show it here. So now this E will be deleted and added there. So that welcome will be coming again here and it is fading away from this side. Then again it will start from there. So this is the logic used for LED display ports. So this logic is common in electronics. So in computer science also this technique is taught as left rotate or right rotate, left shift or right shift. So that's all about the basic operations we have seen upon an array. So that's all about these operations.